So we're starting Unit 1 today. So we're going to be looking at Day 1, which is functions and their properties. So for our first part, we want to just be able to tell if a graph is going to be a function or not. So what we're going to use to tell this is we're going to be using the vertical line test. So what the vertical line test is, you're going to draw a vertical line through your graph. If that vertical line only touches the graph once, in every place you would draw a vertical line, it is a function. If you draw a vertical line and it crosses the graph more than once, then it's not a function. So in our first example here, if we draw a vertical line, so it only touches it once, no matter where you draw these vertical lines, that vertical line is only going to touch the graph once. So it passes the vertical line test, which therefore means it is a function. All right, so if you look at the next graph here, if I draw a vertical line, well, the first one I drew, look, it crosses the graph twice. So this fails the vertical line test, which means that it is not a function. Okay, so to tell if something's a function, you're going to use this vertical line test, draw a line through the graph. If it only touches the graph once, it's a function. If it touches it more than once, like this, then it fails the vertical line test and it's not a function. Okay, so next we're going to talk about if graphs are continuous or not. So continuity of a function is another way to say if it's continuous or not. So a function is going to be considered continuous if it has no breaks. So the types of breaks that we're going to see, it can't have any jumps, no holes, and no asymptotes. Okay. In order to tell if something's continuous, you should be able to take your pen and you're going to always go from left to right like you're reading a book. But if you go from left to right, you should be able to go over the graph and never have to pick up your pen or your pencil to get to the other side. Okay, so this is a continuous graph because there are no breaks in the graph. It keeps going. This doesn't have endpoints on the end, so you can assume that it does have errors, so it will keep going. But regardless, this is a continuous graph. So this says continuous at all x. We're going to be using intervals to tell where things are continuous or later increasing and decreasing, positive and negative. So when we want to write this interval, we are going to be using the x values for our interval. So when we're using our x values, make sure you're looking at the x-axis, okay? Very small x numbers are over here, so I'm going to call that negative infinity. Very large x values are over here, so we're going to call that positive infinity. So because this is continuous for the whole graph, that means for the x values, which we're using, all the way from negative infinity to positive infinity is where it's continuous. Anytime you use positive or negative infinity, you're going to make sure you use parentheses because those do not end on your intervals. So just to make sure you have a little note here, make sure anytime you're doing continuous that you use the x values in your interval. And we'll be using the x values again later. But when you're writing your intervals for continuous, make sure you're using those x values. If it's not certain numbers, it's the whole graph, make sure you're using negative and positive infinity. All right, so now we're going to take a look at when things are not continuous. So we're going to call that discontinuities. There are two types. We have removable discontinuities, which we're going to look at. Those are where we have holes. And then we have non-removable discontinuities. So removable discontinuities, these graphs look almost the same. But removable means that if you were to get rid of the hole that's there, you can make the graph be continuous. So here is a graph, okay? If you run your pencil across it, you would have to pick up your graph because here you have a hole. And so you'd have to like jump over the hole to get to the next part. So that's not continuous, which means it's discontinuous. But the reason it's called removable is because you could literally, that hole has just been removed from the graph. So that's why it's going to be a removable discontinuity. This graph is almost the same. So if you go from left to right, you run into this hole, so it's removable. The only difference between these two graphs is they actually have plotted a point here. So this point is actually where the y value would be, and there's nothing here, whereas there's not an actual y value for this x value here. So these are very similar. Both of these would be considered removable discontinuity because they have the hole. Okay. So then when we're talking about non-removable discontinuity, we have two instances for this. So as you see, if you go from left to right, well, we do have a hole here, but we're missing this whole part of the graph here. So this is called a jump. So whenever you have a jump, okay, like we have here, you have to jump with your pen or pencil, that's going to be called a non-removable discontinuity, okay? You can't just pick that, like it's just not part of the graph like a hole that's been removed. The other type of non-removable discontinuity is called an infinite discontinuity, and you'll see this vocabulary sometimes. Normally we refer to it as having a vertical asymptote because that's what's really going on here. So anytime you have a vertical asymptote, that also makes the graph not continuous, and it's going to be a non-removable discontinuity. Okay, because if you run your finger across here, well, the graph stops and then it picks back up here, so it's not continuous. Okay, so for something to be continuous, the graph has to keep going. There can't be holes, there can't be jumps, there can't be asymptotes. For it to be a removable discontinuity, that's where we have holes. Non-removable can either be a jump or these vertical asymptotes. All right. So next off, we're going to look at increasing and decreasing, and we're going to be writing intervals for that. So before we actually look at what increasing and decreasing is, I want you to make yourself a little note. For increasing and decreasing, we're going to make sure we use our x values when writing our intervals. So whenever they ask you for intervals of increasing or decreasing, just like with continuous, you're going to make sure that you're using the x values in your intervals. Okay, so when you're talking about increasing and decreasing or talking about constant, you're always looking at your graph going from left to right. So when we're looking at increasing, we have to make sure we're going from left to right, like you're reading a book. So if you look at this first graph here, if we're going from left to right, the entire graph is increasing, okay? So from left to right, this entire graph is increasing. So if we wanted to write that as an interval, we would say it's increasing. Now, before I write the interval, it's really helpful if you always put your negative infinity and positive infinity here just to show, okay, because we're using the x values. So it's increasing for the whole graph. So it's increasing on the interval from negative infinity to positive infinity, okay? So then if you look at the one to the right, if you go from left to right, this entire graph is decreasing. Okay, so if we want to write our interval, I'm going to put my negative infinity and positive infinity. We would say the whole graph is decreasing on negative infinity to positive infinity. Okay? Now this last one here is if the graph is constant. So if it's not increasing or decreasing, if it stays the same. Okay, now this entire graph is staying the same. Going from left to right, it's the exact same number the whole way. It's at 2 the whole way, the y value 2. So we can still write an interval for that. We're just saying the whole graph is constant. So we're going to put our negative infinity and positive infinity. And we would say it's constant on the interval from negative infinity to positive infinity. Okay, so these three graphs that we looked at, they were increasing the whole graph, decreasing the whole graph, or constant the whole graph. The last one that we're going to look at here mixes all these together. So I like this example. So we're going to start from left to right, okay? So if you start here, this first little part, that part right there is decreasing. Okay, so if we want to write the interval for that, we got to make sure we're going from negative infinity to positive infinity. We're using the x values. So it starts at negative infinity, and then it's going to stop decreasing at negative 2. So, and they've already written it out here, but it says decreasing on the interval from negative infinity to negative 2. I want you to notice that they use parentheses, and that's what you're going to do every time for increasing and decreasing. The reason is because at negative 2, it's decreasing, and then it changes to constant. So a negative 2 is just the point where it's changing. It's not actually decreasing or constant. It's changing direction. So decreasing on negative infinity to negative 2 with parentheses. Okay? So then if we look at the next part here. So from -2 to 2, it's staying constant, okay? So constant on the interval from -2 to 2. Once again, we're using parentheses there. And then for the last interval, for the rest of the graph, it's increasing. So that starts at 2 and it keeps increasing for the rest of the graph, so you have to use that infinity. So from 2 to infinity, it's going to be increasing, okay? So just remember, and we're going to make a little note, so whenever you're writing your intervals, so when you're writing your intervals for increasing or decreasing, or for constant, only use parentheses. And once again, the reason for that is because at the places that the numbers you're gonna write, it's gonna be changing direction. So no brackets. And make sure you always go from left to right. Okay. So increasing, decreasing, constant, they could all be on one graph. The whole graph might be doing one of them. Just make sure you're using x values and make sure you're using those parentheses.